In this problem, we are given a 2010 gross domestic product in billions of dollars, and we're supposed to find the mean and the median of this data set. And we're also asked if this data set is from the sample statistics or a population parameter. So to find the mean and the median of this data set using our TI-84, all we need to do is to plug in all the data set in our calculator using stat, edit, so push 1, and in list 1 we can plug in all the values that is given to us, and the calculator will automatically give us the value of the mean and the median of this data set. So let's go ahead and plug it in. So after we plug in all the values in our calculator, all we need to do is to push stat and go to calc and push 1 for one variable statistics, and it will ask you to plug in the list number or the type of list that we used in our calculator. In this case, by default it's using list 1, so we don't need to change it, and then just push calculate. Mean is represented by x bar in our TI-84, and it's giving us 289.04. so we can say that the mean for x bar of this distribution is 289.04, and it's in billions of dollars, so we can just put dollars in billions. And the median is going to be, if you just use the cursor, and it will give you the value of the median, which is 173.5. So the median is at 173.5 billions. And to answer the question here about statistics and parameters, we can say that since the given data set is telling us all 50 states, we can say that this data set is population parameters. Now, do these data have a mode? And to find the mode, all you need to do is to look at your data set and find the number which frequently appeared in your group of data set. And in this case, the mode, by looking at the given values, will be 49. Because 49 is the only data set in this group of data that appeared twice. Now, to answer question number 2, so this is number 1, we are given a data set of the incomes in thousands of dollars for a sample of 12 households. So we are supposed to construct a box and whisker plot for these data. Now, our calculator or TI-84 can also generate the box plot of your distribution. So all you need to do is to go to stat, go to edit, and let's use list number 2 for our second problem. So here we have 75, 69, So now that we have all our data set in list 2, so to construct a box and whisker plot, we go to second function y equals, and we are going to turn on plot 1. So push enter and turn it on. So make sure that the highlighted or on is highlighted in your calculator to make sure that it will graph your box plot. And you are seeing two box plots right here. This one is box plot that will show the outlier, and this one is just the regular box plot. So let's go ahead and push the box plot that will show an outlier so that we can find if there's going to be an outlier in our data set. So push this box plot right here. We are not using list 1 because list 1 is for problem number 1. We need to change it into list 2. So second function 2. And now from list 1, we are now using list 2 in our graph. Now this is very important because if you push graph in your calculator, it will not give you the graph of your box and whisker plot. So you need to do zoom. So push zoom N9. So that you can see that there is a box plot generated in your data set. So this will be your box and whisker plot for the data set that's given to us in problem number 2. And to construct it, what we can do is find the minimum value. So push trace, and the minimum value is 69. Our Q1 is 77. Our median is 87. Q3 is 101. And minimum is going to be 144. Notice that 144 is right outside the range. It's because 144 is considered to be an outlier using the 1.5 IQR rule. So our maximum here will be 144. And this data set right here will be our minimum when the outlier is not included in our data set. So if we're going to graph our box plot, our x-axis right here. And since my minimum is 69, I'm going to start at 60. And my scale will be an increment by 10. So the minimum is at 69, so I'm going to have my minimum right here. So that's my mark for my minimum. My Q1 is at 77, so 77 is somewhere here. That's my Q1. My median is at 87, and my Q3 is at 101. Somewhere right here with a maximum of 144. So somewhere here in the middle. So to construct your box plot, we know that the box will be our Q1 and our Q3. And this one will be our median. And this will be our tail. So this is going to be our box plot for this data set, and in this particular question we can also see that this one is skewed to the right, because if you are looking at it as a distribution or bell-shaped curve, so it's not really that bell-shaped curve, but there's going to be a long tail right here, and you grab the long tail with your right hand, so that's why this is skewed to the right. And this is how we generate our box plot using our calculator, and how we can translate it in our paper right here. So for the second problem, we're supposed to find the box and whisker plot of this distribution and check if the data is symmetric or skewed, if there are any outliers, and classify the mild or extreme outliers in this particular distribution. So from our TI-84, so we're working on problem number 3 right now. Let's put our data set in list number 3. So we have 266.7, 136.2, So since we have our data set now, so this data is giving us the 2009 estimates of so going back to second function y equals, we still have our plot right here. And we are using this first box plot which will show us the outliers of our data set. Change your list from list 2 to list 3 because list 3 is now our new data set, and this will give us the 5-number summary and the box plot of our distribution. So zoom 9. So sometimes the TI-84 is lagging, so just quit it and push zoom 9 once again if that happens. So now we are seeing our new data set, and let's go ahead and write down the 5-number summary, which is our box plot in this particular graph right here, just to give us a more descriptive summary of our data set. So minimum, our Q1, median, Q3, and maximum. So minimum, push trace, and it will show you the minimum number of the distribution, which is 10.5. Our Q1 is 21.3. Our median is 51.85. And Q3 is 107 with a maximum of 266.7. which is also an outlier because this graph right here in our TI-84 is showing an outlier. So if we're going to construct our box plot, including an outlier, so 10 to 266, so this one is, I think I'm just going to scale it by 50. So we have 0, 50, 100, 150, 200, 250. So just to sketch our box plot, it's at 10.5, so somewhere here, 21.3, so let's say somewhere here, 51.85, and 107. Maximum of 266.7, so somewhere here. And we know that that is our outlier. So this one is our box. And the median. And this will be the whisker, which is the minimum and the maximum. And we can say that our distribution is slightly skewed. So the longer tail is right here on the right side, so slightly skewed. To the right. What we can do is use the 1.5 IQR rule. Which will verify the outliers to the left of the curve and to the right of the curve. Now, from our box plot, we've seen that there is one outlier, but to compute for it mathematically using the 1.5 IQR rule, we first need to solve for the interquartile range, which is IQR, which is given by the formula of Q3 minus Q1. And Q3 in our 5-number summary is 107. Minus Q1, which is 21.3, and it's giving us 85.7. This is our IQR, and using the 1.5 IQR rule, we're going to then multiply this by 1.5 to verify the outliers to the left of the curve and to the right of the curve. So 85.7 multiplied by 1.5 is giving us 128.55. So this will be the value that we're going to be using to find the outliers to the left and to the right of the curve. So to find the outliers to the right of the curve, we will use Q1, and subtract it with our 1.5 IQR, which is 128.55. So Q1 is 21.3 minus 128.5, or 55, is negative 107.25. And what it means is that any number that is lower than negative 107.25 will be considered to be an outlier. From the box plot that was generated from the TI-84, we have seen that there's no outlier to. Now, to verify the outlier to the right of the curve, so we have Q3. Now we're going to add it to our 1.5 IQR, which is 128.55. So whatever values that we're going to find based on this formula, any number that is outside the range or to the left of this value will be an outlier. So we have Q3, which is 107, added to 128.55, and it's giving us 235.55. So this time, any values that is greater than 235.55 based on our data set or original data set will be considered to be an outlier. That's why we've seen one outlier from our box plot, because the maximum value that we have here is 266.7, and based on the original data set that we have, 266.7 is the only data set in our values or the given values that is more than 235.55. Therefore, 266.7 is considered to be an outlier in this data set that we have in our. We are given the speeds of 31 cars in miles per hour measured by a radar traveling on I-84, and the data sets will be stat, edit. Let's go to list 4, and we have 73, 75, 69, 68, 78, 74, 76, 72, 79, 68, 77. Now, instead of using the box plot, let's use stat, calc, and one variable stats, so that it will just give us the value that we're going to be looking for. List 4 is what we're using. And in list 4, we are given Q1, go down, and Q1 is 69. Q2 is also your median, and it's giving us 73. Q3 is 76.5, and our IQR is Q3 minus Q1. So when you use a calculator, it's going to give us 7.5. So that is our IQR. For problem letter B, we're supposed to calculate the value of the 35th percentile. Now, using our TI-84, there is an easier way on how to find percentile. All you need to do is to have your mean and standard deviation to be able to compute for the 35th percentile of the distribution. So our mean and standard deviation based on our calculator, stat, calc, one variable stats of list 4 is giving us 73 and a standard deviation of 3.851. So let's use 3.8514. So to use the calculator, so go to stats, go to second function vars, and go to inverse normal, which is number 3 in the choices right here. And the area is asking us, or the area that's asking us right here is basically the 35th percentile, which is 0.35. The mu, or the mean, is 73 with a standard deviation of 3.8514. And using our calculator, it will give us the percentile, or the 35th percentile of our distribution, which is 71.51. So our 35th percentile is at 71.51. Now, for letter C, we're supposed to compute for the percentile rank of 71. So let's illustrate 71 according to our distribution. So if we're going to illustrate 71, so the mean of the distribution based on problem letter B is 73. And 71 is below the mean, so let's put 71 right here. So in statistics, what we're trying to look for is the area under the curve at 0.71. So this will give us the percentile rank that we are looking for a speed of 71 miles per hour. So to do this in the calculator, we're just going to push second function vars, and go to normal CDF. And in this case, we are finding, or we are asked to plug in the lower, the upper, and the mean and standard deviation of our distribution. Now the lower value right here is going to be the negative infinity, and to use the negative infinity in our calculator, we push negative, so it's already here by default, but it's negative 1, and e is second function, comma 99. So this is a value that is closer to the negative infinity, so this is what we're going to be using. And the upper value is at 71 because it's going to be from here to here. So 71 is your upper. And the given mean is the mean that we got from problem letter B, which is 73. And standard deviation is 3.8514. So by using our calculator, we're going to be able to find the percentile rank of 71, which is 0.30177. So that means, using our calculator, the percentile rank of 71 which means there are 30.75% of the sample which is going to be the same speed or slower than 71 miles per hour. So this is how do you compute for the percentile rank using our TI-84.